So, in our Explore and Reason, um, I don't know if any of you decided to use graphing to identify the solution, but if we do that, we can write an expression for theater A and an expression for theater B. So theater A is $5.75 per popcorn tub, and we're buying 3 tubs of popcorn. And then we're spending $14.50 per ticket. The second theater, $13 per ticket, and then 3 tubs of popcorn at $6.75 a piece. So what I did was, in a way, set them equal to each other. So 1450x plus 3 times 575 equals 13x plus 3 times 675. And when I do that, I get this green line. This green line, everywhere along this line is 2. So no matter how much we spend here, no matter what that output is, I am at 2 people. So if I go to the movies with 1 other person, the price will be the same no matter which theater I go to. Keeping that in mind, which theater would you choose if you have 5 of you going to the theater? What happens if you put in 5 for X for the first one and 5 for X here for the second one? How does that change your decision? What is the value of X in the equation shown? So our first set of examples, we're going to look at some more complex equation solving scenarios than we saw last week. So when I am looking at this, it does not matter if we add 10 to each side first or if we add 2x to each side first. Either order will result in the same equation. So here that's telling me we have some options. So the first thing I'm going to do is simplify each side of my equation. So we have 3x minus 10 plus 4x on one side of my equation, and negative 2 times the quantity x minus 4, and then plus 9 on the other. So I'm going to combine like terms. 3x and 4x are like terms because they have the same variable and the same exponent. That is something to consider. Okay, so 3x plus 4x is going to give me 7x minus 10. And then on the right side, we need to do our distributive property first. So I'm going to take this negative 2 times x to get negative 2x, and then negative 2 times negative 4 to get positive 8, and then I'm going to add my 9. So here I have some more like terms. I have 8 and 9. So I'm going to keep my 7x minus 10 equals negative 2x plus 17. So here that study tip makes a little bit more sense. We can add 10 to both sides first, or add 2x to both sides first. It doesn't matter. What does matter, though, is that we are consistent with doing the same thing to both sides of my equation. I do like to get my x's together first because I like to make sure that if possible, that I keep my coefficient positive. So negative 2x plus 2x zeroes out, and we have 17 equals negative 10. We bring that down, and then I can't talk today. 7x plus 2x is 9x. I'm going to rewrite that over here so I have some more space. So we have 9x minus 10 equals 17. Now this looks a lot like the equations we were solving on Wednesday and Thursday last week. So I'm going to undo subtraction by using addition on both sides. And we get 9x equals 27. Then I will use division to undo my multiplication, and we get x equals 3. Does this solution work? Well, let's test it. I'm going to go back to my original, and I'm going to put that 3 in everywhere I have an x. And then I'm going to see if this works. So 3 times 3 is 9. And then minus 10. And 4 times 3 is 12. Okay. And then 3 minus 4 is negative 1. Negative 1 times negative 2 is 2 plus 9. Okay. So here we have 9 minus 10 is negative 1. Negative 1 plus 12 is 11. And 2 plus 9 is also 11. So x equals 3 is my solution. Let's try a couple more. I'm going to show them to you and let you work on them on your own. So here is our next equation. What is the value of n in the equation shown? 1/2 times the quantity x minus 4, then minus 7 equals negative 2n plus 6. Let's take a look at how the text prepares this solution. So here we are starting by adding 7. It's going to move that 7 to both sides. So I'm going to add that in because it is skipping some steps here. And that's how we get the 13. So it says, let's move this out of the way. So that 1/2 times the quantity n minus 4 equals negative 2n plus 13. Okay, the next step is I want to undo this 1/2. I can undo a fraction by multiplying by its reciprocal. Or you can think of this as dividing by 2. So I'm going to multiply both sides by 2. So this eliminates, and I distribute the 2 in. Okay. So we have n minus 4 equals negative 2n plus 26. 2 times 13 is 26. Now, there's a couple of things happening here with this n minus 4 equals negative 4n plus 26. They are doing a couple of steps in here. They're going to add 4 to both sides. Okay, so remember, I'm doing that on both sides of my equation. So I get n equals negative 4n plus 30. And then they're moving this negative 4n over by adding the opposite. So n plus 4n is 5n equals 30. This is 5 times n, so I'm going to get my solution by dividing by 5, and you get n equals 6. Okay, so here there are multiple steps skipped in the process, so I tried to fill those in where I could. But this trick of undoing a fraction by multiplying by its reciprocal, taking a number and trading the numerator and denominator, flipping your fraction, if you will, is a really nice strategy to have. So now I want you to try one or two. So the first one I want you to try is 100 times the quantity z minus 0.2 equals negative 10 times the quantity 5z plus 0.8. The second one I want you to try is 5/8 times the quantity 16d plus 24 equals 6 times the quantity d minus 1 and then plus 1. So take your time with these, work through it, and then test your answer to see if it is correct. Here's another example, and there's something unique that happens and some vocabulary we are going to develop from this. So I'm going to rewrite my equation. 4x plus 6 equals 2 times the quantity 2x plus 3. And then I'm going to use my distributive property to multiply the parts inside my parentheses by the coefficient 2. So my 4x plus 6 remains the same. And then 2 times 2x is 4x. 2 times 3 is 6. Hold on here. I have the same thing on both sides. So what happens if I go to get my x's together? Well, 4x minus 4x is 0. So I have 6 on the left. 4x minus 4x is 0, and I have 6 on the right. 6 equals 6. Interesting fact, this is always true. Always true. So when this happens, we get the case of infinitely many solutions. Since this equation is true for all values for the variable, it does not matter what we put in for x as long as we put the same thing in on both sides of our equation. This is referred to as having infinitely many solutions because I can use anything I want for the value of x. Now, there is also the case of when we get something that can never be true. So let's check that out. So here we have 6x minus 5 equals 2 times the quantity 3x plus 4. So I'm going to begin this the same way I did on the previous screen. 6x minus 5. And then I'm going to distribute my 2. So I have 2 times 3x to get 6x. And 2 times 4 is 12. Okay, well, let's keep going here. I'm going to get my x terms together by subtracting 6x from both sides. 6x minus 6x is 0. The negative 5 comes down. 6x minus 6x is 0. Plus 12. Wait a minute. Negative 5 cannot equal 12. This is false. What this tells me is that this is never true. So that means no matter what I put in for x, it's not going to work. Recall that you can assign a value to the variable in an equation to check whether the equation is true. So maybe you test a few things. What if x equals 0? What if x equals 1? It's not going to matter, okay? Nothing we use will work. This is a scenario that we say has no solution. Okay? You can write no solution, or you can write does not exist. Both of those are valid responses when we end up with an impossible situation. So now you try. If I have t minus 27 equals negative 1 times the quantity 27 minus t, will that be infinitely many solutions or no solutions? Another way to phrase infinitely many solutions is to call it an identity, because it doesn't matter what we put in. We get the same thing on both sides. How about part B? 16 times the quantity 4 minus 3m equals 96 times the quantity negative m over 2 plus 1. Close your parentheses. Okay? Give those a try and see if you are infinitely many solutions, no solution, or if a solution exists. So the last type of example I want to look at with you in this lesson is using equations to solve problems. So here is a scenario. Cameron pays 95 cents per song with his current music service. So every song he downloads is 95 cents. A new music download service charges 89 cents per song, but has a $12 joining fee. Should Cameron switch to the new service? Well, let's take a look. We are going to write an equation to represent the cost for any number of songs that is the same for both services. Okay? So the first one, 95 cents per song. That's what is in blue here. There's no extra charge. It is just 95 cents per song. So that's this part here. Okay? Then we have the 89 cents per song plus the $12 sign-up fee. So 89 cents per song plus 12. And we want to know, is it worth it to switch from the blue service to the red service? So first we need to know, how many songs does Cameron need to download to make this worthwhile? So we're going to solve this equation for S. So that's what I'm going to do here when I hit the compute button. Okay. So we'll get our S terms together by subtracting 0.89S from both sides. And then we have 12 equals 0.06S, because 0.95S minus 0.89S is 0.06S. And then we're going to divide both sides by 0.06. 12 divided by a very small number gives us a fairly large answer. 12 divided by 0.06 is 200. Okay? So after 200 songs is when plan A will equal plan B. So should Cameron switch? Yes or no? And why do you believe that to be true? And that's the interpret piece. The cost of the two options will be the same for 200 songs. So here's the thing. Will Cameron purchase less than 200 songs? If so, he should stay with plan A. Will Cameron purchase more than 200 songs? If yes, he should switch to plan B. If you were in Cameron's position, thinking about the amount of music you listen to or download to your devices, which plan would you choose? And let's look at one more. Okay. So there is a third service provider that Cameron finds out about. So he's still with his current plan of 95 cents per song. But this third service has a $15 joining fee, but songs are only 80 cents per song. At what number of songs does this new service become a less expensive option than Cameron's current service? So set up your two expressions, set them equal to each other, and let's look at that important information here. So Cameron's plan is the blue plan from the previous page. So 95 cents per song. Remember we said that's 0.95x. And then we'll go with green for this one, a $15 joining fee, but 80 cents per song. So $15 to join plus 0.80 per song. Or you can use S for song. I use X because my S's look like fives. All right. So set up your equation, solve for X, and help Cameron make a decision.